to another episode from Let's Understand Mathematics. In this video, we're going to be taking a look at some of the laws of exponents. In this particular video, we'll be taking a look at multiplying and dividing exponents with the same base. And then from this video onwards, we're going to be taking a look at power of a fraction, power of a product, and some of the other laws of exponents. So without further ado, let's get to the lecture. So excuse me. So multiplying exponents with the same base, what would we do? So same base, meaning base, as I said earlier, is this number that is underneath the exponent. So the same base, meaning the base is the same. So for example, something like this. See, the base is the same. So the number underneath the exponent is the same. And although the exponents are different, the base is the same. So the base number here is the same. So when the bases are same, these rules that I'm going to show you in this video will apply. If not, then that's something else. Okay, so multiplying exponents with the same base. So let A represent any real number, any number. X and Y represent exponents. And this dot here just to indicate we're multiplying this exponent and this exponent. I didn't want to put an X here because you might confuse it for this variable X here. So product, we're here, so this exponent times another number with an exponent equals the base, and now we're adding the exponents. So when we're multiplying two numbers with exponents, two exponents, we're just adding with the same base. The base stays the same, but now we're just adding just the exponents. So I'll show it to you in action. So we'll start with something easy. 3 squared. This is an exponent. We have a base. We have an exponent written in the top right-hand corner of the base. Then we have another number, and we have another exponent here. So 3, and then see in this example, the base. So the A value in the equation above is the same here, and same for both of these cases. So when the base is the same, the rule applies. If this number was 2 and this was 3, then we can't use this rule that we're going to show you up here, or that we have written up here, won't apply. So I'll just show it to you how this rule works. So what does that mean? So 3 squared times 3 to the power of 3. So let's do it first how we normally do it. So 3 squared, is 9, because 3 squared means you're multiplying the base by itself 2 times. So the base here is 3. 3 by itself 2 times, so 9 times 3 to the 3 times 3 times 3, because 3 to the power of 3 will give you 27. And that shall give you that will give you 243, right? So what about if we follow our laws of exponents? So we say here that when we are multiplying exponents with the same base, the base remains the same, but we're adding the exponents. So we don't multiply the base. We don't multiply 3 times 3 and then the exponents. Some people would do 3 times 3 is 9, and then exponents 9 to the power of 6, and they'll solve. But no, the base stays the same. So just to keep that clear, the base remains the same. But here, we're just adding the exponents only. So here, what are the exponents? 2 plus 3. So the base remains the same. 3 to the power of 2 plus the exponents. We're adding the exponents only. So we get here now 3 to the power of 5. And 3 to the power of 5 will give you 243. And if you look here, you get 243 as well. See how that works? So the key here is when you're multiplying exponents with the same base, you can just add the exponents only. So let me show you another example. Negative 2 to the power of 2. So how would we solve this? See, okay, negative 2, remember I'm just putting brackets, so we're taking the cube, we're taking negative 2 to the power of 3. If the negative is outside the bracket, then that would be something, and that means we're taking 2 to the power of 3, and then that result we are multiplying it by negative 1. But since we put it inside the bracket, we're taking the negative 2 that number, and we are taking it to the power of 3, the whole entire -2. We're not leaving the negative out, just to make that clear. So if the negative's out, you would find your result. So 2 to the power of 3 would find your result, and then you would multiply that result by -1. So just be careful if it's inside the bracket or not. If it's like this, we can just take it like right now. So -2 to the power of 3, -2 times -2 times -2. -2 times -2, negative times negative gives you 4. 4 times -2 gives you -8. We're getting -8 times. Now I'm doing this the regular way. I'm not doing it using the law of exponents right now, and then we'll use it later. -2 times to the power of 2 times 4. -8 times 4 times 4, so negative times positive will give you a negative. -8 times 4, -32. So now let's see. We know our knowledge of using this rule, and our base here is both -2. Well, we will use our law of exponents now. So the base stays the same. We're adding the exponent. So 3 plus 2. So -2 to raise -2, and then we're adding the exponents. So that's -2 to the power of 5. Let's see if that works. We got 4. We get 4. Sorry, let me just do it. We get 4 when we multiply these two. -8, 16, -32. -8 times 4 gives me -32 when I did the other. When I use my law of exponents, I also get the same result as here. So this proves that this law is correct, and that this is how we would use law of exponents to solve a question where we are multiplying exponents with the same base. So that should be pretty clear for you guys. And the base has to be the same. Just keep that in mind. And the base is the same. We can use our knowledge of the law of exponents. And when we're multiplying exponents, the base remains the same. We add the exponents. In some cases, like if your teacher doesn't allow you to use the calculator, you could just leave it like this: -2 to the power of 5. When we're using law of exponents, and your teacher doesn't allow you to use a calculator, then you could do that. Because sometimes you might get an answer like this. Because like for this one, you could add it, you could multiply it easily. But if you get something like this, it would be a lot of work to multiply. So in those cases, when you don't have a calculator, you can use -2 to the power of 16. Or you can just leave it in that form, just to make that clear. So with that being said, this concludes laws of exponents, the first law of exponent that we're looking at this video. So now we will go to dividing exponents with the same base, which is somewhat similar. You would notice that it's basically just the opposite of what we looked at here. So let me just erase this for you guys. A to the power of x divided by a to the power of y. So a both represent the same value, equals a to the power of x minus y. So now we keep the base the same, but we're subtracting the exponents in this situation. So let me give you an example. So we could also put it like this, or we could do it like this. So if you guys want. So 3 to the power of 3 divided by 3 to the power of 2. So we could solve this without using the law of exponents for now, because this is an easy example, because we're using pretty small numbers. But I'll show you how we do this exact same question with law of exponents soon. So 3 to the power of 3, 3 times 3 times 3. So 3 times 3 is 9, 9 times 3 is 27, 27. And then 3 squared, or 3 to the power of 2, 3 times 3, 9. So what is our quotient or result for this question? 27 divided by 9, 3. So this would be our result if we did it the normal way. But sometimes if you get something like 3 to the power of 13 and then 3 to the power of 12, what would you do? Would you do 3 times 3 each time? Assuming that you don't have a calculator, your teacher doesn't allow you it. In that case, we would probably use the law of exponents to simplify it and make your life a bit easier. which again is the purpose of exponents and these laws I'm going to teach you right now. Okay, so 3 to the power of 3 divided by 3 to the power of 2. So here we're using our laws of exponents. We know that if the base is the same, all we can do, a to the power of x minus y. So we're just subtracting the exponents when we're dividing exponents with the same base. So we have the same base here. A values remain the same, which in this case is 3. 3 to the power of 3. So we're going to use our law of exponents. So 3 to the power of the exponent of the first, the one on the top, and then the one at the bottom, the one we're dividing by. So we have our two exponents here in our division problem. So in every division problem, you will have two exponents like these. So now we're going to subtract our exponents. So 3 minus 2, 3 to the power of 1, which gives you, when you assume, so a to the power of 1, remember I showed you that rule in the last video. This is also a rule of exponents too. And then we have a to the power of 0. Okay, so a to the power of 1, sorry, that was the wrong thing. A to the power of 1 is 0. It would be a to the power of 0 would give you 1, but a to the power of 1 would give you a. Sorry, I meant to draw a, I accidentally draw it as 0. So, assuming 3 to the power of 1 gives you a, which in this case is 3. Remember the example when we did the normal way, we got 3. So see how the laws of exponents work here? That is why I'm showing you both, how to do both. So, assuming that this was something that you didn't have a calculator again, you would leave it as 3 to the power of 13. In those kind of cases, when you have big numbers, but in this case, you can leave it as 3 to the power of 1, or we can solve it and get 3. So, that being said, that is multiplying and dividing exponents with the same base, an introduction to some of the laws of exponents. So, in the next video, we'll be taking a look at taking the power of a product, power of a fraction, and we will go from there. So, thank you very much once again, and we'll see each other soon.